Having considered the applications and end systems at the edge of the network, let's next consider the access network, the network that physically connects an end system to the first router, also known as the edge router, on a path from the end system to any other distant end system. Figure 1.4 shows several types of access networks with thick, shaded lines and the settings, home, enterprise, and wide area mobile wireless, in which they are used. Figure 1.4, access networks. Home access, DSL, cable, FTTH.
अच्छा, ये जो एक्सेस नेटवर्क है इसको आपने बिल्कुल भी एक्सेस लेयर के साथ कंफ्यूज नहीं करना है। जो डिवाइड किया गया है नेटवर्क को, एक एक्सेस नेटवर्क को और कोर नेटवर्क को डिवाइड किया गया है। कोर या बैकबोन नेटवर्क उसमें जो है हमने डिवाइड किया गया है इस बुक के अंदर, ठीक है। इसको एक्सेस लेयर के साथ कंफ्यूज नहीं करना आपने।
FTTH, fixed wireless, and LEO satellites. As of 2023, more than access of the households in Europe and the USA have Internet OECD 2024, although a digital divide in access exists around the world and among different demographics. Global Digital Inclusion 2025. Given this widespread use of home access networks, let's begin our overview of access networks by considering how homes connect to the Internet. Today, the three most prevalent types of broadband residential access are digital subscriber line, DSL, cable, and fiber to the home, FTTH. A residence typically obtains DSL internet access from the same local telephone company, telco, that provides its wired local phone access. Thus, when DSL is used, a customer's telco is also its ISP. As shown in figure 1.5, each customer's DSL modem uses the existing telephone line exchange data with a digital subscriber line access multiplexer, DSLAM, located in the telco's local central office, CO. The home's DSL modem takes digital data and translates it to high-frequency tones for transmission over telephone wires to the CO. The analog signals from many such houses are translated back into digital format at the DSLAM. Figure 1.5, DSL Internet Access. The residential telephone line.
अच्छा, इसमें आप ये देख लें कि ये होम फोन है और ये जो है DSLAM है, जो ये टेलीफोन नेटवर्क और इंटरनेट को, डेटा नेटवर्क को बिल्कुल जो है तरह करता है और दोनों को सेम वायर पे आगे सेंड करता है। और यहाँ पे स्प्लिटर लगा हुआ है, इनकी फ्रीक्वेंसीज जो है वो डिफरेंट होती हैं। जो यानी कि डेटा की फ्रीक्वेंसी वाली चीज़ें हैं वो इधर आ जाती हैं, वो उनको ये होम पीसी पे डेटा भेज देता है, और जो फ्रीक्वेंसी वॉइस की थी हैं वो यहाँ से या फ़ोन पे चली जाती है। और सेम इज केस, जब यहाँ से कोई चीज़ जाती है तो DSL मॉडेम उसकी फ्रीक्वेंसी चेंज करके DSLAM पे भेजता है। यहाँ पे चेक करता है कि यार ये को डेटा है या ये आपका वॉइस है, टेलीफोन नेटवर्क है, तो वो डेटा को ना डेटा इंटरनेट वाले पे भेज देता है।
Line carries both data and traditional telephone signals simultaneously, which are encoded at different frequencies. A high-speed downstream channel in the, a medium-speed upstream channel in the 2, an ordinary two-way telephone channel in the 2, band. This approach makes the single DSL link appear as if there were three separate links, so that a telephone call and an internet connection can share the DSL link at the same time. We'll describe this technique of frequency division multiplexing in section 1.3.1. On the customer side, a splitter separates the data and telephone signals arriving to the home and forwards the data signal to the DSL modem. On the telco side, in the CO, the DSLAM separates the data and phone signals and sends the data into the internet. Hundreds or even thousands of households connect to a single DSLAM. The most recent DSL standard, ITU DSL 2019, provide for up to downstream over short distances and up to upstream transmission rates. Because the downstream and upstream rates are different, the access is said to be asymmetric. The actual downstream and upstream transmission rates achieved may be less than the rates noted above, as the DSL provider.
अच्छा, ये जो एसिमेट्रिक है ना, एसिमेट्रिक कम्युनिकेशन आपकी वो है जिसमें जो स्ट्रीम और डाउन स्ट्रीम है वो डिफरेंट रेट्स पे होती है।
Provider may purposefully limit a residential rate when tiered service, different rates, available at different prices, are offered. The maximum rate is also limited by the distance between the home and the CO, the gauge of the twisted pair line, and the degree of electrical interference. Engineers have expressly designed DSL for short distances between the home and the CO. Generally, if the residence is not located within to the residents must resort to an alternative form of internet access of the CO.
इसमें ये बताने की कोशिश की है कि अगर DSL जो है वो शॉर्ट डिस्टेंस के लिए होता है, अगर रेजिडेंस आपकी विदिन कुछ एक लिमिट है उस किलोमीटर्स के अंदर नहीं है, तो वो फिर आप किसी जो कंपनी ऑफिस उसके अंदर नहीं है, तो वो जो है इंटरनेट के लिए आपको कोई इंटरनेट जरिया जिसका वो देखना पड़ेगा। वो आगे हम देखेंगे वो क्या हो सकता है।
While DSL makes use of the telco's existing local telephone infrastructure, cable internet access makes use of the cable television company's existing cable television infrastructure. A residence obtains cable internet access from the same company that provides its cable television. As illustrated in Figure 1.6, fiber optics connect the cable head end to neighborhood-level junctions, from which traditional coaxial cable is then used to reach individual houses and apartments. Each neighborhood junction typically supports to homes. Because both fiber and coaxial cable are employed in this system, it is often referred to as hybrid fiber coax, HFC. Figure 1.6, a hybrid fiber coaxial access network. Cable internet access requires special modems, called cable modems. As with a DSL modem, the cable modem is typically an external device and connects to the home PC through an Ethernet port. We will discuss Ethernet in great detail in Chapter 6. At the cable head end, the Cable Modem Termination System, CMTS, serves a similar function as the DSL network's DSLAM, turning the analog signal sent from the cable modems in many downstream homes back into digital format. Cable modems divide the HFC network into two channels, a downstream and an upstream channel. As with DSL, access is typically asymmetric, with the downstream channel typically allocated a higher transmission rate than the upstream channel. The DOCSIS and of N standards define downstream bit rates and upstream rates of and respectively. As in the case of DSL networks, the maximum achievable rate may not be realized due to lower contracted data rates or media impairments. One important characteristic of cable internet access is that it is a shared broadcast medium. In particular, every packet sent by the head end travels downstream on every link to every home, and every packet sent by a home travels on the upstream channel to the head end. For this reason, if several users are simultaneously downloading a video file on the downstream channel, the actual rate at which each user receives its video file will be significantly lower than the aggregate cable downstream rate. On the other hand, if there are only a few active users and they are all web surfing, then each of the users may actually receive web pages at the full cable downstream rate, because the users will rarely request a web page at exactly the same time. Because the upstream channel is also shared, a distributed. Multiple access protocol is needed to coordinate transmissions and avoid collisions. We'll discuss this collision issue in some detail in Chapter 6. Although DSL and cable networks currently represent the majority of residential broadband access in the United States, an up-and-coming technology that provides even higher speeds is fiber to the home, FTTH, Fiber Broadband 2025. As the name suggests, the FTTH concept is simple: provide an optical fiber path from the CO directly to the home. FTTH can potentially provide internet access rates in the gigabits per second range. There are several competing technologies for optical distribution from the CO to the homes. The simplest optical distribution network is called direct fiber, with one fiber leaving the CO for each home. More commonly, each fiber leaving the central office is actually shared by many homes. It is not until the fiber gets relatively close to the homes that it is split into individual customer-specific fibers. There are two competing optical distribution network architectures that perform this splitting: active optical networks, AONs, and passive optical networks, PONs. AON is essentially switched Ethernet, which is discussed in Chapter 6. Here, we briefly discuss PON, which is used in Verizon's FiOS service. Figure 1.7 shows FTTH using the PON distribution architecture. Each home has an optical network terminator, ONT, which is connected by dedicated optical fiber to a neighborhood splitter. The splitter combines a number of homes, typically less than, onto a single, shared optical fiber, which connects to an optical line terminator, OLT, in the telco CO. The OLT, providing conversion between optical and electrical signals, connects to the internet via a telco router. At home, users connect a home router, typically a wireless router, to the ONT and access the internet via this home router. In the PN architecture, all packets sent from OLT to the splitter are replicated at the splitter, similar to a cable head end. Figure 1.7, FTTH Internet Access. Fixed Wireless Internet, FWI, has also become a popular internet access technology. FWI not only provides high-speed residential access, but does so without installing costly and failure-prone cabling from the telco's CO to the home. With Fixed Wireless, using beamforming technology, data is sent wirelessly from a provider's base station to the modem in the home. A Wi-Fi wireless router is connected to the modem, possibly bundled together, similar to how a Wi-Fi wireless router is connected to a cable or DSL modem. In addition to DSL, cable, FTTH, and FWI, low Earth orbit, LEO, satellites are increasingly being used for broadband internet access, particularly in rural and remote areas. Companies such as SpaceX's Starlink deploy large constellation of satellites, providing high-speed access with signal propagation delays much lower than with geostationary satellites.